Okay, in this video I'm going to be talking about EtherChannel, the basics, and how everything works with it. So hopefully this is the one-stop shop for Ether channels. Okay, I'm CCNP Seth, let's get into it. Now, Ether channels, or you may know it as link aggregation, on the Cisco interface it's actually called port channels, but it's all pretty much the same thing. Now what Ether channels or link aggregation is where we bundle several physical Ethernet links into a logical communication channel, meaning we're going to bundle, let's say, 4 links together and the device is going to see it as one logical link. Now when we have these 4 links or multiple links, traffic is load balanced between the member links. Load balancing across port channels is performed by a hashing function selected over a frame's address field. So this could be layer 2, layer 3, or layer 4 headers. So based on how we set it up, we will look at those address fields, perform the hash, and then that will determine which links we're going to take. The hashing function is deterministic, which means all frames in a single flow will always produce the same hash value. I like to call this as link reservation or lane reservation, because every time a flow comes in, I'm going to be evaluating the same exact headers. So depending on if it's coming from one specific IP address going to a specific destination address for that flow, I'm always going to be using that same link. Now when we compare more than one header field, let's say I use the source and destination ports in layer 4, I'm going to be comparing those two, do this XOR operation or the exclusive OR operation, and that will determine which link it'll take. Now if you don't have the power of 2 links, as in if you don't have 2, 4, or 8 active ports in a port channel, then link utilization is not evenly balanced. So if you want to have true load balancing, the best way is to have 2, 4, or 8 links. Now right here you can see depending on how many links you have or how many links that are active, you can see the loadout here. So if you have 2 links here, you're always going to go from either left to right, left to right, left to right. So if we have 8 packets, one link is going to take 4, the other link's going to take 4 as well. If we have 3 links, then we kind of share it and we say 3, 3, and 2. And then you get to see if we have 7 links, you get to see that this first link is going to be double the load versus all the other links here. So that's why it's best to have 2, 4, or 8 links. Okay. Now when it comes to link aggregation, discovery, and configuration, their port channels, they are very specific on how they need to be set up, okay? Now this section is going to be the most important when it comes to troubleshooting and setting up Ether channels. Ports assigned to a port channel must have identical settings, period. As in physical ports, they need to have the identical settings together to make this port channel. They need to have same speed and duplex setting, same operating mode, so don't have them in dynamic mode, either be trunk or access. If we are bundling access ports, then they all need to be part of the same access VLAN or else they won't bundle correctly. When you're trunking, same trunk type, same allowed VLANs over it, same native VLAN, same. Now, each physical port in the port channel must also have the same STP cost, so please don't go into the physical interfaces and change them themselves. Also, these ports cannot be part of a span configuration. Now, I got a lot of this information from the CCIE version 5 book, and they also say depending on the version and the platform that you're using, please go to the configuration guides for the most up-to-date settings, okay? Now, when a new port channel is created, an interface port channel is automatically created with it, which is good. You shouldn't create the interface port channel first and then add physical links to it. You should not do that. This new interface will inherit the configuration of the first physical interface added to the port channel. This is very important. If I go into an interface and then I say channel group 1 mode, desirable, well, at that point, is that physical port actually a layer 2 port? Because if it is, I will create a layer 2 port channel. If that physical port on the switch is a layer 3 port, as in a no switch port, then the port channel is automatically created as layer 3. That's very important. If other physical interfaces are added to the same port channel, then their configurations will be compared to the port channel's configurations. So let's say I already have one physical interface into the port channel and it's working. And now I want to add in a second interface, physical interface, to the port channel. Well, when I put that command, channel group 1 mode desirable, it's going to compare the physical port configs to the port channel configs. If they differ, that's that second bullet right here. If they differ, the physical interfaces will be suspended from the port channel and will not be working, and will not be a working member until that configuration is identical. Okay? Now, configuration changes to the port channel will only be applied to non-suspended member ports. So if they are in a suspended state and then you change the configs on the port channel, it will not be applied to them. Okay, so commands applied to the port channel are pushed down to only those physical ports who are matching. Right. Therefore, do not match port channel configs to the physical interfaces. Do it the other way around. If you're trying to troubleshoot and just say, oh, let me match the port channel configs to the physical port configs to add it into the bundle, to add it to the bundle, don't do that. Do it the other way around. Have the physical interfaces match the port channel and then make the changes on the port channel. So because these are so strict, follow these guidelines when you config port channels, okay? Do not create the interface port channel manually before bundling the physical ports. Now, I said that before. Let the switch create it because it'll automatically associate it with it. I've seen on physical devices, you create the port channel and then you go into the interface and say the channel group number to match that port channel interface. They won't make the association. I've seen that before, so don't do it. Let the switch create it itself. When you remove a port channel, remove the interface port channel first so it does not cause issues with a port channel with the same number if it is recreated later. Okay, so if you want to get rid of the port channel, remove the port channel first. Done and done. Make sure the physical port configs are identical before adding them to the same port channel. Okay, we kind of just learned that. If physical port configs differ from the port channel configs, correct the physical ports first, then change the port channel. You cannot switch between layer 2 and layer 3 modes without recreating the port channel. That is kind of important. If you want to turn a layer 2 port channel into layer 3, your best bet, just take all the configs away, remove the port channel, recreate it in layer 3 mode. Okay, make sure the physical interfaces are layer 3, then do the channel group command, and then that'll auto create a layer 3 port channel. When resolving an issue with error disabled ports under a port channel, be sure to shut them down, shut the physical interfaces down, and then the port channel down. Then reactivate all of them. If the problem persists, remove the port channel and unbundle the physical ports, and then recreate the port channel. There are two ways that you can configure a port channel. You could do it statically or dynamically. Static is not recommended because it is prone to switching loops. Static configuration does not negotiate with the other switch on which links are eligible for bundling, so this could cause a loop. Right? Always use some sort of negotiation protocol so both sides know, oh yeah, hey, we're actually in an ether channel, rather than one side saying, I'm in an ether channel, I don't know about you, but right? So then we can cause a loop here. Okay. So how this would work is, let's say on this secondary root switch right here. Okay. He thinks those two ports are bundled. The access switch down here, he does not think they're bundled. So what happens with spanning tree is the secondary root bridge right here, this switch right here, he's going to send one BPDU out a physical link because yes, it is in a port channel, but STP is still going to take a physical link. It's going to do the hashing algorithm. Now, depending on what it is, in this picture, it shows that it is going this way. It is going on the left link. This access switch says, oh, okay, I see that there's a loop here. I am going to block it. But I am not physically sending out a BPDO on this secondary link from the secondary route. So access switch thinks that there's no loop there. So he's going to put this port into the designated port. Now that we show that there are two designated ports, now we just created a loop. Very bad because we statically configured this. This could also be a temporary loop because let's say you configure this to be a static ether channel first, and then 5 minutes later you go down to the access switch and do the static config. Within those 5 minutes, you could have a switching loop right there. If you're running a rapid spanning tree or MST, then the STP dispute mechanism would detect that there's an issue and then it would actually stop the loop there. Cisco has implemented EtherChannel misconfig guard on its switches, and it ensures all source MAC addresses of BPDUs are the same over bundled links. If they differ, then the entire port channel will be error disabled, but misconfig guard does have its limitations. All right. Now, when it comes to dynamically configuring this, it is strongly recommended to use the open standard 802.1ax. This stands for Link Aggregation Control Protocol, or LACP. Cisco has its own PAGP proprietary protocol. However, when you bundle things together, you're not just bundling switches together anymore, especially in the data center. I believe Nexus switches don't even understand PAGP. PAGP allows for a maximum of 8 links in a port channel. Switch will not add any more than 8. The only configurable PAGP parameters that you can have is the frequency of the PAGP messages. So normal mode, I'm going to send a PAGP message down the link every 30 seconds. I can put it in fast mode where I will send a PAGP message down the physical port every 1 second. And then that's the config right there. PAGP timer, normal or fast. The negotiation modes for PAGP is either auto or desirable right here. Auto or desirable. Passive and active is for LACP, but they do the same thing. Auto and passive waits on the other side to send messages, and then desirable and active initiates the negotiation and actually sends the messages. Now for LACP, it allows a maximum of 16 links to be in a port channel, but only 8 of them are active. So just in case that 8th link fails, since I have 8 other backup links, LACP will choose which link to come in and bring it as active. So if a link fails, the switch in charge will choose which link to bring in as the active link. And the switch in charge is the switch with the lower LACP system ID. This is broken down into 2 parts. There's a priority and then a MAC address. So this is very similar to STP. And the switch in charge will choose the link with the lowest port ID, which again is broken down into 2 parts, priority and port number. And the way that you configure this is in global config mode. You could say LACP system priority 0 to 65,000, and then go into the physical port and say LACP port priority 0 through 65,000. Okay. Now this ends my presentation on ether channels. I hit a lot. I went pretty quick, but I think I've explained how all of it works, and and I hope this gives you a better understanding on how to do it. So I hope this was informative for you, and I'd like to thank you for viewing.